Next, I will show my experience on how to rapid prototyping assembly happily. I'm a real-time system firmware engineer. It means that I often need to write code in assembly. Also, I learned Python in 2000. So today I'll introduce how to use Python to make a rapid prototype in Python. I'll give an introduction to the problem I want to solve, and then how to rapid prototype in Python. Then how to convert Python to assembly happily. Okay. In the communication systems, we often need to meet backward compatible. So we need to exchange capability between modems. So a parser is required to parse those data online. So programmers like me often need to write the code in assembly because we need to reduce memory footprint. On the chip, SRAM occupies a lot of areas, and that means a lot of money. So we're forced to do that. Okay. So to exchange capabilities, we often use the tree structures. So I'll briefly illustrate how two modems exchange these trees. This is the modem transmit its capabilities. It's just an illustration. It's a tree structure. So first, the modem transmits its capability. Then it will receive the response. So we can see that the tree structure is different. Then we need to combine it and make the final decision. So either one of the modem will make the final decision. Yeah. Then these trees will be encoded into octet stream. That is the real data we want to transmit. And some bits are used to mark the end of different levels. Like we might mark the end of this tree, and then and the other end will know that it is the end. And because of the future compatibility, so we need to make sure every leaf is required to parse, because even we don't support it right now. So now we know the problem we want to solve. So let's code it in assembly directly. It's very hard. Normally we will, if it's for signal processing functions, we will prototype in MATLAB or NumPy. Yeah. Nowadays I just switched to NumPy because it's, IPython notebook is very easy to use and free. But MATLAB is totally useless in building this parser. MATLAB is not for octet processing. So then other engineers do that in C, but for me, I don't like it. So I decided to give Python a try in order to find the best architecture. This parser was written like 5 or 6 years ago. At that time, I had been a full-time assembly programmer for at least 4 years. That means I wrote assembly every day for 4 years. But this code will be eventually maintained by other programmers. At least I wish when I started to write it, right? You don't want to maintain it forever. So maintainability is very important to this problem because tree parsing is already a very hard problem. Then if it's coded in assembly, it will be harder. So I need to experiment different architectures for finding for simplicity, clarity, and maintainability. That's okay. That's why Python is used. So I'll give a definition for rapid prototype. Rapid prototype is, like architectural design. I mean, building buildings. Rapid prototype could be building a scale model, and sometimes will be dumped later. This is what I thought at that time. I thought the Python code is just for me to learn the best architecture. But later I will say that it's used as an offline parser, so it's not dumped. But at that time, I thought it would be dumped. Anyway. So, how to do rapid prototype for assembly? At that time, I had done rapid prototyping for C many times, and I enjoy doing that in Python because it actually saves a lot of time for debugging. Normally we 20% of time is coding, 80% of time is debugging, and if you do a rapid prototype in higher level language, you actually save the 20% might be increased to 30%, but the 80% of debugging time will be, I guess, at least will be half of that. So you actually save time. But how can we apply this rapid prototype to assembly? I won't go into too much details because this system is still running, and I can't disclose too much. But after so many years of writing assembly, I realized that C is actually a thin wrapper of assembly. It means that when we write assembly, we actually know like how C pointers are implemented, how C function pointers are implemented or something. So what you can apply to C can also easily apply to assembly. Of course, not the syntax. The syntax of Python and C is very, very close, but the syntax of assembly and Python is different. So let's see the characteristic of assembly programming on DSP. I mean digital signal processor, not data science. Okay. Normally we use bitwise arithmetic or branch. It's common. Function pointers are used a lot. And it's word address mode. It means, okay, hard to describe, but just, okay, word addressable. All variables are global in our system. Normally, I prefer table-driven programming, and it's easily done in Python. So our design consideration is code size must be as small as possible. So we need to try a lot of combinations. And we want it easy to maintain. That means easy to add handlers of leaves, like by other engineers. And you don't need to trace parse engine very often. Actually, I've done that like 3 times during the past 8 years. So once you code it, you don't need to trace it very often. But if you need to trace parser engine, it should let you grab the idea very, very fast. That is how Python help us. Okay. So for bitwise arithmetic or branching, I use the. It's not easy to perform bitwise directly in Python, so I choose the true/false list. And in assembly, functional pointers is actually registers, and you do a jump. So, but in Python, what is a function pointer? We just use the name as in a list. It's like this. A is a function. Then you put it in a list, and then you call it by this syntax, and it will become a function pointer. At least we treat it as a function pointer. For global variables, that's not a problem in Python, right? Then the tree parser architecture is the most important part. And I tried a lot of different combinations on these architectures. So I built several prototypes for this tree parsing or leaf handling, because I need to know what is the best architecture for other programmers, not for me, right? And during coding in Python is actually, I always say that Python is the only language that can let you write the code and chat at the same time. It's very easy to program. So, but if I code in assembly, I need to totally focus on the on those bitwise arithmetic branching, because if you just lost a bit, your program will be buggy. Yeah. So normally we know that if we want to parse the tree, we can use stack or not. For me, I want it to be as simple as possible. So actually I tried the stack version, but I think it's not so straightforward for other programmers. Okay, I mean programmers not trained by computer science. Okay, I need to introduce our team. Normally, DSP team is composed of DSP team members are of double E background. So so they didn't take the compiler or something. So it's hard for them to understand those structures. And the number of first level nodes are fixed. So I just make it an array. Not there is no stack. There is no stack. Yeah. And Python code, every time I need to debug this part, Python code plays an important role for me to pick up again. Because it's, for me, I seldom write comments in Python, because actually Python is very, very close to literary programming. Yeah, so I don't write many comments. So for the leaf handler parts, this part will be added or modified by other engineers very often. So I tried to make it as simple as possible. That means, so my structure will be like, if transmit mode, just generate octets for this leaf. In receive mode, just compare and save these octets with our capabilities. Then insert this handler routine to the table according to its tree position. So, and it's very consistent across these leaf handlers. This is what. every program is created twice, first in Python, then in the assembly. So then we try to, the previous part is the experiment part. Took me about maybe several months, yeah. But later, then I tried to convert Python to assembly. Every experienced assembly programmer has his or her own design patterns. That means when we saw the control structure, then we know how to write the assembly. Yeah. I just illustrate some of them. Like if then else, we just do a bit test flag and branch to else part if the bit is clear or set. It depends on, it's up to you. And do the then part. If the then part is finished, just branch to the end. Then the else part, just do the else part. This is if then else in assembly, but I didn't specify any architecture. For switch case, I prefer table-driven. So I'll put the value, if the value is from 0 and incremented by 1, then I will make it the array index. But if it's not, I will use an array of 2 items. Then just make your subroutine address put in the array. And an end marker to mark the end of this array. So for the leaf handlers, this structure is consistent across all leaf handlers. So once other engineers try to write one, then they know how to write others. Maybe sometimes just copy and paste. So just skip 2 register as, okay. The parser will handle all other things, like give you the registered R0 to store octet string buffer, and give you R1 as the argument, the pointer to input or output octet string. And once you finish this leaf, then it will help you to write to mark the end of tree or something. So programmers just focus on how to write this leaf, this parameter. And this is, for me, when I write this, I just, it's more like a copy and paste, but you need to type it. So I just take the Python code as reference and then type in my design pattern in assembly. So I didn't get the agreement or approval from my previous company, and IC Design House is conservative on this part. So I didn't say any protocols or show my assembly code. But this is just like concept or what I did. And I think it's very successful on building a sustainable architecture, because it's actually, this architecture still runs for 8 or 9 years. Actually, I wish them can rewrite it or something, but actually the thing that it's already enough to use. So it lasts for many years. So the basic idea is illustrated. So during the converting Python to assembly, I was like a typist. I just watch I just watch the Python code and then type into assembly code. Although an expensive one, you know. So at that time, more than 4K word of assembly were finished in a week or two. Actually, it's a very fast speed for writing assembly code. Yeah. And the most important part is that it's the debugging time is very short, because every time there is a problem, I just use this Python code as a comparison. And then I can locate the bug very, very fast. So for me, what's the happy part? The first, coding in Python. I just said is you can code in Python and chat at the same time. So that's happy, right? And then converting from Python to assembly, like a typist. So actually at that time, I don't need to think too much for converting them. Just write. Of course, the Python code later it was used as an offline parser. Actually it's not so offline. It's just we run the code in the DSP processor, and then it transmit and receive. We can log the argtext it receives and transmit, and then use this Python code to parse it. So, yeah. So again, I maintain another Python code at work. So coding assembly is actually very challenging for this kind of task. And coding assembly without a plan is disaster. So when you design something new and you want to experiment different software architectures, I think Python is very, very useful for trying different combinations, for building different architectures. Because if you do that in assembly, it will cost you a lot of time to debug. And so Python is very good rapid prototyping building tool for assembly. Yeah. So after so many years, I can still feel how happy I was at building those rapid prototyping assembly. And wow. So, do you have any questions?
Have you encountered any gap when you converting from the Python to assembly? Like that, if some ideas you written coding in the Python is easy, but when you writing in the assembly is very difficult.
Yeah, like I said, at that time I was full-time, 4 years experience assembly programmer. And the architecture I experimented, is actually very easy to handle at the leaf handlers. That is the most work is at the leaf handlers. So when I convert it, it's actually very easy to write it. Although assembly is not straightforward, but their structures across different leaf handlers are the same. Handlers for like node 1, node 2, node 3 are different. Only in table position and the content they're processing. But their structures are all the same. So you just it's just copy and paste from the other assembly, or you just write, just see the Python code and convert it to assembly. Just with the slightly different content you write.
As you speak, you say the code create twice in Python and assembly, but as I recently attend a Coursera.org course, Nerd to Tetris. They have an easy way use the many language to generate from the other language to assembly. I also try this way, but I don't know why you don't add your translator to your Python code to generate assembly code directly. This is my question.
Okay. That is like toolchain or code translator, right? Let me think. This is rapid prototype. So at the time I wrote it, actually I was trying to find the best architecture. So I need to experiment different architectures. That was my intent. So I didn't try to use code translator, or 8 or 9 years ago, not many people use toolchain or translators. Yeah, right now I use a lot of toolchain, or not code translator, just toolchain. But I don't need to handle this kind of problems anymore. Yeah, I didn't try it. But for me, rapid prototype is already a very. Oh, okay. Sorry. sorry. I need to explain it because programmers in EE field cannot accept the toolchain or code translator's idea. Actually, I did a version of it's a table, and use the table to generate those handler code. But it's not accepted by them. Yes. They feel secure when they write assembly. So that's what I use. I think I need to try the best architecture, also for human readable. Yeah. I think that's the.
So do you do any verification once you've transcribed your assembly that it's correct according to the Python?
We compare the transmit and receive outputs. Yeah, this problem is hard, especially for communication systems. I don't know. I don't have any good solutions for that.
So just manually you try to make sure that you did it right and do a lot of testing.
Yeah, because I think that's why they have so many we call it plug fest. It's an interoperability test for different communication standards. And I'm sure they don't have any verification tools for the communication protocols. Yeah, so they just gather people around and we just, if there are 4 vendors, we just gather 4 vendors around and locked in the lab for 1 week, and then we try to transmit or receive these things, and then try to find a different implementation. If there are, normally we need to use the spec, the communication specification, and then try to discuss. For the same sentence, might be understood by different people in different ways. So I don't think there is very good verification tools. I know there are some papers to do that, but it's not used in the industry. Yeah.
Okay, so is there any questions? Okay, so let's give Albert a big hand for his great talk.